next speaker is,
Hi.
hello, George Moromisato. I hope I'm saying that
Yeah,
approximately
perfect.
right.
Perfect.
And
Go ahead.
I just wanted to introduce you just real quick. You can already see the title of the slide. Uh, so yes, we're going to talk about creating a modding system for roguelikes. I'll let you have the floor. Take it away.
Yeah, thank you. Dylan almost like segued right into it, talking about how, he thought he should have created a modding system. So maybe, maybe this will help other people trying to create a roguelike. Hi, I'm George Moromisato. I'm the creator of Transcendence, which is kind of roguelike adjacent. It's a game of space combat and exploration, but it's got a ton of roguelike elements like procedural generation, permadeath, and it's heavily, heavily inspired by NetHack. That really was like kind of one of my major influences growing up. And it's got a modding system, and there's a ton of people. It's got a very robust modding system, and the players have been just amazing at creating some huge a modding system. So I want to talk about some of the sometimes painful lessons that I've learned in creating this modding system, and hope that people who are creating roguelikes today can kind of learn from that. What makes a good modding system? Easy to use, powerful, flexible. All those. It's interesting. You kind of have to think. What do you optimize? But let me back up a step. First, let me ask, what makes a good roguelike? Because I think this is kind of the key for us. We want to kind of make sure the modding system supports what's unique about a roguelike. What makes a good roguelike? Meaningful choices, replayability, this kind of stuff. Yeah, I think all this makes sense, and I think we've seen this in roguelikes. But I want to focus on one specific feature of roguelikes that I think we'd all agree is critical, and that's combinatorial complexity. Roguelikes have this awesome thing where the different items interact with monsters, the items interact with each other, effects interact, special attacks interact with special defenses. And so you get this really, really interesting matrix of complexity, of combinatorial complexity when you mix one item with another. That's kind of, I think, one of the cool things about roguelikes, in my opinion. The problem is that's really hard to mod. Combinatorial complexity, once you create that in a game, it's very hard to create mods for that. Why is that? Let's talk a little bit about how combinatorial complexity gets created in a game. Let's just take a stupid little sample game. Here it's got 3 items. I'm gonna put it here. It's got like a steel sword, an ice sword, and a flaming sword, and it's got 3 different creatures. It's got an orc, a yeti, a dragon. Pretty kind of generic game, but you can already see that because of combinatorial complexity, when each type of sword attacks each type of creature, you get 9 different possible effects that you kind of have to figure out, okay, what happens? And so you as a programmer have to now figure out for each of those combinations in this matrix, what happens, and you have to program it basically as efficiently as possible to get these, different effects. Steel sword, maybe it just does normal damage, but hey, look, a flaming sword, we might decide we want to do extra damage against the ice, creature, the yeti, but we do a totally different effect on the dragon. So, how do we do that as programmers? We might do that just in this very simple case as just a combination of if statements. Say, we just kind of do, if it's a sword, then then do this. Here's the effect. Now, when you add modding to this system, this is where it gets a little bit more complicated. So in modding, imagine that I want to add, a new type of weapon. I'm going to add a fireball here. And let's say also that I'm going to add a new type of creature, a magic creature. Well, with the fireball, for sure, now I have to figure out what's the effect of the fireball on these existing, creatures in the game, these 3 creatures that are already existing. And when I create my magic creature, I have to figure out, well, what happens when these existing weapons, hit my new creature? I'm going to have to make those decisions. And even worse, even harder, is imagine that these two, that the fireball and the magic creature, the beholder, came from different mods. In that situation, how do we decide what the effect of the fireball is on the beholder? If they come from different mods, they can't coordinate with each other. So it's really hard, to figure out exactly what the effect, what the effect is. So this is why modding is difficult in these kind of roguelikes with combinatorial complexity. So how do you do it? How can we handle this problem? Well, traditionally we just fork the code. This is roguelikes have rich history of creating new versions, effectively mods, I guess, total conversion mods, by just forking the code. You just take the code and fork it. When NetHack, and all these others kind of came through forking, and basically they decided, well, we're just going to add a ton of new magic creatures and a ton of new items, and we're just going to write brand new code. So that works, and I actually think that's a very effective method. But obviously, as the games get larger and more complicated, then modding is harder. Plus, forking is you kind of restricted to the set of people that can actually fork the code. You have to be a full-on developer to fork the code, and so you're restricting. There's a bunch of people that now can't participate in that system. So for something like forking, it's great because you don't have to worry about it. You just make the source code open source, and now you just let people do whatever they want. But obviously, it's tricky because you have to be an expert programmer, and users can't combine mods. Now if someone does do a mod by forking the entire source code, you can't just willy-nilly combine unless you yourself are a programmer and try to combine it. So what are some other methods? What's another method of doing mods on roguelikes? Another one, oopsie, what just happened? There we go. Another one is what Dwarf Fortress does, and that's to just simulate essentially the physics of the game world. So in something like Dwarf Fortress, the way we do it, and this is not literally how Dwarf Fortress does it. This is just kind of an example of how they might do it. You can imagine that they would design a series of forces and materials. This is just a kind of simple example, where you define a bunch of forces like piercing and bludgeoning and heat damage and that kind of stuff, and then you define a bunch of different types of material, armor, glass, whatever. And the engine, the simulation engine, decides what happens when a certain force hits a certain material. What happens when cold hits skin? What happens when cold hits glass? And you just make those decisions in the engine. Then when it comes time to creating actual items and monsters, you just do it in terms of these forces and materials. So it's a lot easier. So let's take an example. Here's how we solve this problem of combinatorial complexity in something like Dwarf Fortress. For a steel sword, we can say that it does piercing damage, and we say that an orc just has normal skin. So when we attack an orc with a steel sword, the engine just does whatever happens when you try to pierce skin. So the engine is just kind of following that logic. And now adding fireballs and adding magic creatures is actually relatively simple. You basically say, well, the fireball, does heat damage, which is a type of force. You say that the magic creature has a type of, a material like armor. And then you let the engine just do whatever it does, that it wants. And you can add special properties, special tags, special ways of saying, that certain materials are, let's say, immune to magic, or certain, forces do extra this or extra that. But the engine, the simulation engine handles all the details. That just makes this a lot easier. So a simulation like Dwarf Fortress, you can just modify with data files. You can just define your creatures, define your items in terms of those more primitive forces and materials, just as data files. You don't need to do any programming. You don't have to, know how to do C++ or anything in classes and objects. You just, define the files. Dwarf Fortress, for instance, does a lot with just data files. And they've gotten really, really far. There's some very, very sophisticated mods in Dwarf Fortress just by manipulating the data files. And it's all because of the strength of the engine. The simulation engine is just amazingly powerful. So the downsides, of course, are you have to have a pretty complicated and robust simulation engine, and it'll take you years of programming. It can take a long time, and I guess you have to be as smart as the Adams brothers to do it too. So it is tricky. This is not for everyone. But even simpler simulations can get some of these advantages. The one other downside, or at least thing that you kind of have to watch out for, is the drunk cat effect, which I'm sure you all know the story of the drunk cats in Dwarf Fortress. And the issue there is that you can't always predict exactly what's going to happen in the simulation based on the inputs, because there's just, again, there's so many combinations, and the more complicated the simulation is, the harder it is for you ahead of time to decide what's going to happen with all these inputs. So that's why you get these emergent effects which are good, but you also get emergent bugs which are not as good. And so that's definitely a tricky thing that you have to make sure you get straight. Another method of doing modding in roguelikes is scripting systems. And this is a much more traditional thing that you do. And has its own set of pluses and minuses. Caves of Cud, I'm going to use kind of Caves of Cud and Transcendence as an example. Transcendence is the game that I created, which has a ton of modding scripting systems. Caves of Cud also has a very robust scripting system based on C#, and so it's like super powerful. Here's an example of how something like that might work. And blur your eye. If you're not a programmer, blur your eyes. I'm going to try to talk you through it. It's really not. This is not nearly as scary as it looks. Imagine that you're pointing the code where you're attacking. An attacker. I'm going to highlight some stuff. An attacker here attacks some defender, and we roll some damage based on whatever the attacker does. Let's say if it's a dragon, it does whatever. 2d8, 2d12, whatever. And then normally, skip this call for a second. Normally, we just would decrement whatever damage from the defender hit points, let's just say, something simple. And then if the defender hit points go below 0, well, the defender's dead. But to support modding, what we're going to do here is right in between these two calls, we're going to call the mod, or potentially a series of mods, and tell them that an attack is happening. They're basically saying an attack has happened, and here's the defender, and here's the attacker, and here's how much damage we're going to try to do. And now the mod gets a chance to basically do whatever it wants. The mod with some script code looks at the attacker, looks at the defender, looks at the damage done, and changes the damage. So it might decide, well, in this, because of this buff, the attacker does extra damage to this particular defender. So I'm going to change D, damage done to, or I'm going to double it, or add 10 or whatever. And then the rest of the code keeps running. And you can add more of these calls to script at different points to handle different cases. So here's another example where I'm just elaborating on the same method to attack. But now I'm going to call in two places. I'm going to call a place to an on attack event and an on defend event to kind of alter both the a buff to the attacker and maybe a bonus for the defender. And so now you can have kind of different effects depending on which is which. So the attacker may get some bonus to damage, but also then we might call another mod with an on defend call, and it might do some lower the amount of damage because of some protection. So now you can see how this would actually be relatively simple to do. If I add a fireball, I just have to create an on-attack event, and in the on-attack event, I do whatever it is that I want the fireball to do. I do fire damage or whatever. And for the magic creature, maybe I handle the on-defend event and check to see if the attack would harm this creature, and if not, I'd set it correctly. Again, this works with even if the mods are independent. If I have one mod that does the fireball, it gets the on attack event. In a different mod, there might be a beholder with the on defend event. If they both happen to be in the same game, then we just end up calling both events, and it works. And neither mod programmer has to worry about whether they are combined. So this is how we get these combinations, and that is just it really helps a lot. It's really pretty cool. The risk on some of these scripting systems is because they are very complicated, is that it does get really complicated. It's not quite as bad as having to understand all the source code when you fork it, but you still have to understand some bit of programming and some bit of scripting, and particularly as the calls get more the events that you can override get more complicated, it can get pretty hard to understand. So for example, in Transcendence, eventually as players asked for more and more ways to modify the game, I ended up adding events at multiple places to do buffs. So it wasn't just when the attacker attacks, do they get a bonus? But it's, do any of the attacker's items give them a bonus? Do any of the allies of the attacker have a bonus for the attacker? Do any of the allies' items give bonuses to the attacker? So you end up just like adding more and more calls to allow you to do more interesting mods. The only other risk with scripting systems is because you're basically allowing people to execute code while you're running the game, it does end up exercising the underlying engine pretty heavily. And if there are any bugs in the engine, guaranteed the modders will find it and you'll crash the game. So it's always tricky. I get a ton of reports in Transcendence of people saying, Transcendence crashed. And of course, it turns out it's some mod that's doing something just a little bit, that I didn't expect. And the whole engine is crashed. So the quality control is definitely a challenge in these cases. So quick sum up. So for scripting systems, very flexible. Easier to implement than like a full-blown Dwarf Fortress simulation, something like that. But obviously there are some, there is complexity and there's some interaction that you have to worry about. So like anything else, all these different methods have their good points and their bad points. So let me try to summarize a little bit, the lessons learned now that I've given you kind of an overview of how modding systems work. The first one is to really rely on multiple systems. That's one thing that a lot of these games do. Even Dwarf Fortress, for instance, even though it does have a very rich simulation, it also provides a runtime way of kind of modifying game state, and that's much closer to a scripting system. It works great for doing UI mods, where you do quality of life type of mods. Caves of Cud, same thing. It's got a ton of different ways of doing modding. You can mod the data files. Or you can do full-blown scripting. Same thing with Transcendence. You can kind of get in it at multiple points, and so doing that, I really think helps to get a larger community. You don't just get the programmers; you get some people who are just doing flavor text and graphics and that kind of stuff, and that's super important for the community. Another thing that I heard from talking to Brian Bucklew of Caves of Cod and Tarn Adams of Dwarf Fortress is you got to do this from the start if you can. It is harder to retrofit some of these systems at the end. If you can start from the beginning, and you don't have to have it all worked out. You don't have to figure out exactly how your modding system is going to work, but you have to kind of know that you're going to do it. And put in at least some of the hooks and understand kind of the basic architecture of how you would do this, and that really does help. That helps a lot. And that brings me to another. This is my obligatory. I put a picture of my dog in all my talks, so obligatory picture of my dog. The other thing that is really cool that you should do is always essentially use your own system. When building out your game. So if you are building a modding system in your roguelike, use it for your own first-party content. So in Transcendence, for instance, this has been super helpful. All the missions that the player can do, the different types of ships, the different types of items are all implemented in the modding system itself. And that just helps immensely. I mean, number one, it makes it obviously a lot faster to create content, but it also exercises the modding system so that when players go to do the mod, it more things work, and it works both ways. What happens a lot is that modders will request certain features in the modding system that I hadn't thought of. And after I add them, I realize, oh wow, now I can use that feature to add this other type of content, or this other different type of weapon. So it's always great to be able to use your own modding system. It helps immensely. Another thing I learned a lot that I think also helps a ton is this concept of leaving white space for others to build. This is super important. In Transcendence, for instance, there's a galactic map. It's a space game, so there's a map. But not all of these you can kind of see the different zones. But not all of these are actually filled in the base game. In the base game, really kind of only these central areas are filled in. The other ones are left blank, just left unimplemented. So it's left for other players to or for modders to kind of create whatever they want in those spaces. It's got just a little bit of a hint of what's there, just in terms of maybe you might have some flavor. Maybe this is the pirate realm, or maybe this is the fire realm, or whatever. So you can put a little bit of flavor, but then you let the players kind of fill that in by themselves. I love this concept of white space as kind of a way of enticing players to do things. Like another minor thing that we do in Transcendence is there's weapons that you can attach to your ship, and so we have like a Mark III howitzer, and we have a Mark V howitzer, but we don't have a Mark IV howitzer. So what might that look like? And we don't have a Mark VI howitzer. So what could that look like? So players get a chance to kind of fill that in for you, and that gives them something to mod. So I think that's cool. One last thing. This is kind of my last slide. The other thing that I find really cool about this is, in general, when you, as a developer, you have an asymmetric relationship with your players, right? You're producing content, you're the developer, you're creating content, and your players are consuming the content. But when it comes to modding, it's not like that. It's symmetric. You're both creating content. You're both creating things for other players to play. And so treating those modders as equals, as part of the development team, I think can really pay dividends. You should share as much as you can in terms of the development process. Even kind of background material about the themes and the setting of your world and the characters, to help the modders kind of create things that fit into the world. The other reason I think this is so cool is that modding is one of the few cases where the players, your players, are actually developing skills that are really real world skills, right? I mean, programming, design, writing, creating images. These are like actual skills that will help you, in careers and in jobs and life. And so being able to support that, being able to help people to develop those skills, I just think is so cool. I mean, that's one of the reasons I love, having a modding system. Brian Bucklew also told me, for instance, that one of their mods for Caves of Cud, they ended up hiring the modder into the development team because just the mods that they created were so good. So another great example of how modders can just be it just can be such an interesting part of the development team. So I hope that if you're a roguelike developer, you think about modding as part of your system. And if you're a player, I hope you get into modding and you look at how you can mod your favorite roguelike, and see if you can get into it. So thanks a lot, and thank you. And if there are any questions, let me see.
Oh, cool. Thank you so much. That was so insightful. I really appreciate calling out the hey, not everybody who wants to mod your game is going to be a programmer.
Exactly. No, I mean that's exactly, and that's a painful lesson because I certainly started with that assumption, but it obviously ended up not being true, and I'm glad that my players kind of beat me over the head and said, help me do it so that I can do this without being a programmer, and I think it's super useful, super awesome.
Yeah, totally. All right, we do have some questions looking at the note wall here. How do you make sure that you maintain backwards compatibility for mods when you release updates? Yikes.
Right at the heart. This is probably one of my Transcendence players because I'm not very good at this. It's a very hard problem. It's a very, very difficult problem. The thing I found in Transcendence, or the thing that I instituted very quickly, is obviously just version numbers. Version numbers, help a lot. So at least you need to know the version of the API that a particular mod kind of was built on. So instituting that from the beginning will help you, because then once you read the version number, then you can't go back in time. So you got to make sure it's there from the beginning. So it's really important to make sure that when people create mods, that you have put a version number in somewhere, somehow. And then now the tricky part is now your engine basically has to have different behaviors based on the version number. So Transcendence does this in a couple of cases. When it loads a mod with an older version number, it kind of modifies its behavior to make sure it's compatible with the old way of doing things. I don't do that a lot because it's pretty expensive development-wise, and it gets complicated. But sometimes it's worth it, especially on the transition, kind of from one version to another. It's kind of helpful to do that.
Right on. Thank you. I think we're just gonna do one more. Do you have recommendations on documentation for mod systems?
Another excellent one. Another excellent one, which again, painful lesson, is very, very hard in Transcendence. For the first couple versions, it was the players, honestly, who did the documentation. It was really sad, because it's because it's a time-intensive process. The thing that I'm doing now as much as possible is basically make sure that the documentation is embedded in the code. So I'll give you an example. When I create a new function for scripts to call, I make sure that the system that I have for kind of registering these new functions and making them available to the modding system have space there for, here's how you call it, here's some documentation for it, so that it kind of all goes together. And so whenever I add a new function, it kind of documentation, you have to add it. It just won't compile without it. And similarly, if you change things, in the code, you can right there change the documentation, and then have tools that basically programmatically output this documentation. So no matter what version of the program you have, you can always kind of generate your documentation. So I found that to be super helpful. But Transcendence doesn't do the best job. That's I certainly didn't start that way. That's kind of more and more. This is another one of those things where if I'd started that way from the beginning, things would be a lot easier. So this is another thing that I absolutely, I'm glad someone asked, because if you're going to do it, you should start from the beginning and do it that way.
And I know it's a hard sell. Like, the people who want to write code and the people who want to write docs are hardly ever the same people.
Oh yeah. No, absolutely. Yeah. And again, I think enlisting the community is fine for that too. The wikis, again, if there's a way to, and in Transcendence there is, we kind of, what players do a lot of times is they would dump out the list of functions. They do a diff between the previous version's output, and then they kind of say, these are the new functions that showed up in this version, and then people would start doing it on the wiki. So again, not ideal, but like you said, different players just do different things and like to do different things.
That's fantastic. Don't ever underestimate your players.
No. I mean, I love our community. We just have some amazing people in the community who are, and Dylan was saying the same thing, right? He in the previous talk, he was saying how he was so amazed at what the community could do, even without a formal modding system. I think that is a super universal lesson.
Yeah, absolutely. Cool. Well, thank you so much.